Ask an AI about something obscure, and it can give you an answer that looks completely legitimate. A precise date, a convincing historical figure, maybe even a legal brief citing court cases and judges that sound entirely real. Until someone checks and realizes none of them ever existed. That's what makes AI hallucinations so strange. The problem isn't just that AI can be wrong, it's that it can be completely wrong and still sound completely certain. So why can one of the most sophisticated systems we've ever built confidently invent something that never existed? Most people imagine a language model working like a giant database. You type, "What is the capital of France?" The AI looks somewhere inside its memory, finds greater than France to Paris, and retrieves the answer. Except that isn't really what happens. A language model doesn't simply pull a stored answer from a drawer. It generates a response piece by piece. Based on patterns learned during training, it keeps asking something closer to, what should come next? And predicting a convincing continuation is not the same thing as verifying that it's true. Type, "The capital of France is." The model processes the context and assigns different probabilities to what could come next. Paris gets a very strong signal. So the model generates Paris. Then it generates the next token, and the next, and the next. That basic mechanism can produce code, essays, explanations, stories, and answers. But here's where it gets interesting. What happens when the question is obscure? What happens when the factual signal is weak, but the model still knows exactly what a convincing answer is supposed to sound like? Imagine asking for a niche academic paper that doesn't exist. The model may not have reliable information about the actual paper, but it has seen the structure of academic citations countless times. An author name, a publication year, a journal title, a volume and issue, a DOI. It knows the pattern. So even when the underlying fact is missing, the structure of a convincing answer is still there. And that gives us the first big idea. Hashtag AI can know the shape of an answer without knowing the answer. That's why hallucinations often don't look like gibberish. They look polished, specific, authoritative, because the structure can be perfectly familiar, even when the content inside it is completely fabricated. Now you might be thinking, fine, if the model isn't sure, why doesn't it simply say, "I don't know"? That sounds like the obvious solution. Except this isn't only a knowledge problem, it can also be an incentive problem. Imagine a 100-question test. Correct answer, +1 point. Wrong answer, 0 points. I don't know, 0 points. If you're uncertain, what gives you the best chance of scoring? Guessing. Because guessing gives you at least some chance of being right. In many traditional evaluations, a correct answer is rewarded, while admitting uncertainty may receive little or no credit. So if uncertainty isn't rewarded properly, guessing can become the better strategy. Hallucination isn't just a knowledge problem, it can also be an incentive problem. And this is where human psychology makes the problem worse. When something sounds confident, we tend to assume it knows what it's talking about. Compare these two sentences. I think the treaty might have been signed around 1847, and the treaty was ratified on June 12, 1847. The second feels far more authoritative, but fluent language is not proof. A model can produce perfect grammar, precise dates, professional formatting, and confident wording without the underlying claim being correct. That gives us another rule worth remembering. Hashtag presentation confidence is not factual confidence. So why not make AI much more cautious? Whenever an answer seems uncertain, just stop. The problem is that this creates the opposite failure mode. Make the model too willing to answer, and it hallucinates. Make it too cautious, and it starts refusing questions it actually could answer. So the real challenge isn't never answer when uncertain, it's know when to answer, know when to check, and know when to stop. And this leads to one of the biggest changes happening in modern AI systems. Instead of forcing the model to rely only on what it learned during training, we can give it tools. Web search, documents, databases, calculators, code execution, external systems. Now, the model doesn't always have to jump directly from question to answer. It can do something closer to question, search and retrieve, evidence, reason, verify, Answer: this doesn't eliminate hallucinations. A system can still retrieve a bad source, misread a document, or draw the wrong conclusion. But it adds something pure generation doesn't have: external evidence. So the next time an AI confidently gives you a fabricated claim, don't assume the system suddenly stopped working. Something much simpler may have happened. The factual evidence became weak, but the generation continued, and the model produced the linguistic shape of a valid answer, without enough evidence to support what it was saying. That leads to the most important idea in this video. Hashtag, hallucination doesn't mean AI stopped working. Hashtag, it can happen because AI kept working after the evidence ran out. Or, put even more simply, the evidence stopped, the generation didn't. Once you understand language models through that lens, a lot of their strange behavior starts making more sense. But that raises another question. When you type a prompt and press send, what actually happens inside the AI before the first word appears? That's what we'll break down next.